So in this video, we are going to look at one more example where we're given, where we're going to talk more about revenue than profit. So a company makes two products. The demand equations for the two products are given below, a P equation and an X equation, where P is the price and X of weekly demand of product one, and Q is the price and Y the weekly demand of product two. Okay, so when we do revenue, the R of XY for this, we have to take into account both demand functions. So my first one is demand for product one, which deals with X. So remember, when we find the revenue, we take the price and we multiply by the number of units, which would be X. And then we also have to do that for my Q equation, which we're going to add, but this is in terms of like with Y being my unit. So this is going to be Q times Y. And the total revenue is going to be the sum of those two price demand equations times their units. So I would do for this one, P times X. So I'm going to multiply every term by X. So it's going to be 200X minus 3x squared minus xy. So I multiplied everything in here by an x. I'm going to multiply everything in Q by a y. So it's going to be 150y minus xy minus 2y squared. And then I'm going to look for any like terms for my revenue function. Okay, I have a minus xy and a minus xy. That looks like the only one. So I'm going to put them in order. So negative 3x squared minus 2y squared, negative xy and negative xy is minus 2xy, and then the plus 200x and the 150y. So that is my revenue function. Then, so that's part A. B says find the price that the company should charge for the product to maximize revenue. Then we want the maximum revenue. And then in D, they said use the second derivative test to confirm that it actually results in a max. And the second derivative test is finding that D and then compare it, like seeing if it's greater than or less than the 0, and then same with the partials. Okay, so for B, we're going to find the maximum. So we have to find the critical points. So I'm going to find R of X and take the derivative of this with respect to X. So I get negative 6X, 0, since there's no X. This is going to be, I'm going to put the 2Y in front, and the derivative of X is 1, so it's just negative 2Y. And then 200X is 200. Okay, R of Y, so with respect to Y, 0, negative 4y minus 2x, and the derivative of y is 1, 0, and then 150. Okay. I have to set both of these equal to 0. Okay, when I do that, I'm going to move the 200 to the other side by subtracting it. And I get 0 minus 200, which is negative 200. Okay, so this is the same thing. I'm going to move the 150 over and subtract it, so I get negative 150. And I want them to line up. So I'm going to put the x first and then the y. So this is the first example we're doing when, again, we want to solve this by elimination, but neither of the coefficients for x or y are the same number opposite signs. So I need to multiply one or both of the equations by something to get either the x's to have the same coefficient or the y. So it really doesn't matter. Let's just do the x's because either one is pretty straightforward. So if I have negative 6 and 2, well, I can make a negative 2 a 6 by multiplying by a negative 3. And again, I want it to be opposite signs. So when I add them, they add to 0. So I'm going to multiply this second equation by negative 3. I'm not changing my first equation, so I'm leaving that the same way. And I get a positive 6x plus 12y which equals a positive 450. Now, if you're not sure about that, or maybe when you did elimination, you always like multiplied them by each other, and that's fine. You could have multiplied the second equation by like a 6 and the first equation by a -2. You just need them to be opposite signs, or else you have to subtract them. And a lot of students make more mistakes that way. And you could get both of the x's to be 12s, and that's fine. When you solve for x and y, you'll get the same value that I did when I do it this way, as long as you don't make a mistake. So either way is fine. But if you add -6 and 6x, they add to 0. 2y and 12y is 10y. -200 plus 450 is 250. And then if I divide 250 by 10, I get 25. So then I'm going to do either equation. It doesn't really matter. I guess we'll just do the first one again and plug in 25 for my y and solve for x to get the x coordinate. So this gives me -50 equals -200. I'm going to add 50 to both sides. Okay, I get -6x equals -150. I'm going to divide by a -6, and I get x to be 25. So my critical point is 25, 25. Okay. So that's how many products I most likely should sell to maximize my revenue. They just said product 1 and product 2. Okay, so again, I do have to confirm it, but they asked me to in D, so I'm going to wait to do that in D. In C, they asked for the max revenue, so I'm just going to plug in 25, 25 into my revenue function. Let me just write the revenue function again, and just always do the simplified one. That's probably the easiest. Okay, so everywhere I see an X, I'm going to plug in 25. Everywhere I see a Y, I'm also going to plug in 25 this time. I'm just going to type it all in at one time. So you can do that as well and make sure you're getting the same answer. Okay, and so when you do that, you should get 4375, so 4,300. Okay, so that's the maximum revenue. Again, just to write out, we would do 25 units of A and 25 units of, of product 2. They call it product 1 and 2, not A and B. And then D says verify it is a max using the second derivative, and that's how we always do these. So we're going to find our D, which again, before we do that, I need to find all my partials. So I need R of XX, R of XY, and R of YY. Okay, so R of XX, let's come back to R of X. We're going to take this with respect to X. So the derivative of negative 6X is negative 6. This is a 0, this is a 0. So it's just going to be negative 6. Okay, doing that same one with respect to Y. Okay, this is a 0, this is a negative 2, and that's a 0. So I just get negative 2. And then R of YY. So here's my R of Y. The derivative of negative 4y is negative 4, and then nothing else has a y, so all of them are 0. So it's just negative 4. So remember, D is this formula. Okay, again, it's at the critical point, but we only have that one critical point, and again, they're all constants, so it really doesn't matter. I don't have to plug them in. Okay, so we get negative 6 times negative 4 minus negative 2 squared. So we get 24 minus 4, which is 20, which is greater than 0. And we can see that R of XX is less than 0. So again, we have a max at 25, since D is greater than 0 and R of XX is less than 0. One last thing I want to do, because on the homework, when you find your partial with respect to X and Y, you're going to get decimals, and your system of equation is going to look something more like this. And I know if you take an 06X class, they cover this, but I know everyone's coming from different places, so I wasn't sure how comfortable students are with this. So I just wanted to do an example of how to solve this system of equations. So I think the easiest way is to kind of get rid of all the decimals. And to do that, what we're going to do is, if you find the last decimal place, like here, these are all 2 decimal places, so it's to the hundredths place. And because it's to the hundredths place, what you can do is, if you multiply this whole equation by 100, which is legal because you're going to multiply everything by 100, you can get rid of all the decimals. And the same thing would be true for the second one. So this is also the last decimal place for all of them is the hundredth place. So I can multiply this by 100 and get rid of all the decimals. So if I do that, like on that first equation, I'm just going to get, if you do 100 times 0.03, you're just going to get 3x. And 100 times 0.02 is just 2y. And then 100 times 3 is 300. And then if I do this, 100 times 0.12 is just 12x. 100 times 0.24 is 24y, and 100 times 6 is 600. And now it's just easier to figure out, like, again, I need to solve them by elimination. I can get rid of the x's or the y's. I'm actually going to do the y's because they're opposite sign. And I can make a negative 2 a 24 by multiplying it by 12. And then I don't have to worry about a negative. So if I do that, I'd get 36x minus 24y equals 3,600. I don't have to change this equation. And now I can add the 2 equations. I get 48x. These cancel. Equals. Sorry, let me rewrite these. These are really sloppy. So this is 3,600 and this is 600. It's going to give me 4,200, and then I can divide 4,200 by 48. Okay, and so then I get X to be 87.5. And these aren't supposed to be there, so just ignore those. And then I'm going to plug that in to get Y. Again, it doesn't matter which equation I do. Oops, I need to plug it in for X. Okay, so 3 times 87.5 is 262.5. I'm going to subtract this. Which gives me 37.5, and then I'm going to divide by -2. Gives me -18.75. Okay, and most of the ones you'll do, you'll get whole numbers. I just made this up, which is why. And so this would be my point. And it should work that if you plugged it in like to these equations, it should work for both, where you would get 3 if you plug it in to the first equation. Like you can always do that quickly to just check it. So if you plug it into the first one, you do get 3. And then if you plug it into the second one, you should get 6. And you can plug it into the original just to make sure you didn't make any mistake. Okay, and if I do that, I also get 6. So I just like plugged this in for X, this is for Y for each one, just kind of quickly in my calculator, made sure I got the right answers. But I just did that to help you with the one on the homework where you will get decimals, and it will make it easier to do this. I mean, you can also go from this and just like multiply this first equation by 4 and make this like, or -4 to make it -0.12, and it would also work. But I find students prefer not to work with decimals, and so this makes it a little bit easier. So just let me know if you have any questions then.